Welcome you all to the video lecture on signals and system. Today we are going to discuss about basic signal, which is also called as elementary signal or standard CT signal. Okay. So the first signal is given by step signal. Step signal is defined as x of t equal to a for t greater than or equal to 0. So what is the meaning? Only for t greater than or equal to 0, the amplitude is a. Okay. So here they have given that x of t is equal to a for what values of t? For 0 to infinity. Okay. So for 0 to infinity the amplitude is a. So you can continuously draw a signal like this. Okay. For t less than 0 the amplitude is 0. So this side from minus infinity to 0 the amplitude will be of 0. Since it is looking like a step, okay, so this signal is called as a step signal. And the next signal is unit step signal, which is also called Heaviside unit function. Here the amplitude is a if you take a value as 1, okay, then we can denote that particular signal as unit step signal, which is denoted by u of t. Okay, for u of t the amplitude is 1 for t greater than or equal to 0 and 0 for t less than 0. So for 0 to infinity the amplitude will be of 1 continuously. For minus infinity to 0 the amplitude will be of 0. Okay. So here the amplitude is a, that is common step signal. Here the amplitude is 1, that is specifically unit step signal. Unit step signal is denoted by u of t. Okay. And then next signal is ramp signal. Ramp signal is defined as x of t equal to 80 for t greater than or equal to 0. So for that, if you want, you can substitute and see the values. Okay. For example, t takes the values from 0 to infinity. So what is x of 0? A into 0, right? Wherever you have t, you have to substitute your of t. Okay. So a into 0 is a 0. 2a, 3a and so on. It will be t value takes from 0 to infinity. Only few set of values we can take and then we can plot and we can continue the signal up to infinity. We can just draw the rough diagram. Okay. So for 0 t equal to 0 the amplitude is 0. So for 0 the amplitude is 0. For t is equal to 1 the amplitude is 1a. Okay. For t is equal to 2 the amplitude is 2a. For t is equal to 3 the amplitude is 3a. So you will actually have the dots like this. Okay. If suppose you have 4 t equal to 4, it will be a 4a, right? So you will have dot like this. So all these dots you have to just connect like this. Okay. So this is your general ramp signal. If it is unit ramp signal, you have to take a value as 1. So r of t, specifically unit ramp signal is denoted by r of t, which is given by r of t equal to t for t greater than or equal to 0. So what happens? When t equal to 0, r of 0 is a 0. When t is equal to 1, r of 1 is 1. When t is equal to 2, r of 2 is 2. Okay, and so on. So for t equal to 0, the value is 0. For t is equal to 1, the amplitude is 1. For t is equal to 2, the amplitude is 2. For t is equal to 3, the amplitude is 3. You will have dot like this. Just connect all these dots and it will not stop with the 3. It will be going on up to infinity. Okay. So the increasing signal is nothing but a ramp signal. Next is parabolic signal. Okay. So parabolic signal is given by x of t equal to a t square by 2. So similar substitution. Okay. Just substitute t equal to 0. You will get 0. T is equal to 1. 1 by 2. 1 by 2 is nothing but what? 0.5. 0.5a. Okay. So for 1 you will have 0.5a. Okay. For 2, when I substitute 4 by 2 is nothing but 2a. So for 2 you will have 2a. When I substitute t equal to 3, 9 by 2 is 4.5a. Okay. For 3 you will get 4.5a. this, just connect all these dots and it will continue up to infinity. So you will have a parabolic curve like this. Okay. Similarly, the same thing, just take a is equal to 1. Anyway, time value will remains the same. So here you have to remove all a, 0.5, 2 and 4.5. So for 0 it is 0, for 1 you will get 0.5, for 2 you will get 2, for 3 you will get 4.5. So connect all the dots, you will get a parabolic signal like this. Okay, that is a unit parabolic signal, and specifically unit parabolic signal is given by P of t. Okay. So unit step signal is denoted by U of t. The value is 1 for t greater than or equal to 0, and ramp signal is given by R of t. The value is t. Parabolic signal is denoted by P of t. The value is t square by 2. So when you compare these three values, okay, what do you infer, or which mathematical operations you can relate with U of t, R of t and P of t? Can you guess? U of t value is 1, R of t value is t, P of t value is t square by 2. Okay, when you see these values 1, t square by 2, what do you remember? With which mathematical operation do you remember? Yes, it is integration. When you integrate 1, you will get t. When you integrate t, you will get t square by 2. Similarly, when you differentiate t square by 2, you will get t. When you differentiate t, you will get 1. So what is the relationship between unit step, unit ramp and unit parabolic? When you integrate unit step signal, you will get unit ramp. When you integrate unit ramp signal, you will get unit parabolic signal. When you differentiate unit parabolic signal, you will get unit ramp. When you differentiate unit ramp, you will get unit step signal. Okay. So that is the relationship. Okay. So unit ramp signal is obtained by integrating unit step. Unit parabolic is obtained by integrating unit ramp. Similarly, unit step is obtained by differentiating a unit ramp. Unit ramp is obtained by differentiating a unit parabolic signal. Okay. And the next signal is a pulse signal, which is easy. Okay, pulse signal, which is also called as rectangular pulse signal, is given by x of t equal to a for t1 to t2. Okay, so for t1 to t2 only the amplitude exists, that amplitude is a. Unit pulse signal, okay, pi of t is given by 1 for t modulus of t lesser than or equal to 1 by 2. Actually, whenever you have modulus of t can take minus value also, plus value also. Okay, so you can write 2 is lesser value minus 1 by 2. You can write it as, okay, minus 1 by 2 lesser than or equal to 2 lesser than or equal to 1 by 2, meaning that t varies between minus 1 by 2 to 1 by 2. So this only you are writing in a short form as modulus of t lesser than or equal to 1 by 2. So pi of t equal to 1 for minus 1 by 2 to 1 by 2. So only for this duration the values are 0. Okay. So I will give one more example. Suppose if you have like this, how will you write the range? You will write it as minus 3 to 3. Okay. So these things you have to remember. So next signal is impulse signal, which is also called as delta function. Impulse signal is given by del of t equal to 0 for t not equal to 0, and when you integrate del of t dt, you will be getting a amplitude a. Unit impulse signal, which is also called as direct delta function, is given by del of t equal to 0 for t not equal to 0, and integration of del of t dt is equal to 1. Okay, so in simple, actually you consider impulse signal. Impulse signal is one which exists only at t equal to 0. Here only it will exist, okay, and its amplitude it goes up to infinity. Okay, for other values and all the values are 0, but you cannot represent infinite amplitude in your signal, correct? So we are considering a area. Okay, area of the unit impulse signal is nothing but 1. So we are always for unit signal alone. Okay, okay, So at t equal to 0, we will denote area, which is the value unit impulse signal area is nothing but 1. For other signal does not exist. Okay. So actually it is, if you want, you can consider it as a pulse signal. Okay. So this pulse signal will have duration 0 to t, the amplitude is 1 by t. So actually what I am saying, impulse signal will exist only for t equal to 0. So what happens when t equal to 0, this becomes 0. 1 by 0 is nothing but infinity. Okay. But what about your area? Area of this signal is nothing but 1. Okay. So always for unit impulse signal alone, we are considering the unit impulse signal, which we will denote here as 1. Okay. So just t is equal to 0, there you will represent. Okay. For other values of t, the impulse signal does not exist. Triangular pulse signal. Triangular pulse signal is given by 1 minus modulus of t by a for modulus of t lesser than or equal to a. Again, how will you write this range? It will be written as minus a to a. So only for these values the signal exists, for other values the value is 0. So let me consider what happens when I have by a get cancelled. So you will get 1. So 1 minus 1 is nothing but 0. So at minus a the value becomes 0. Similarly at t is equal to a by a equal to 1. So 1 minus 1 is nothing but 0. Here also 0. So when you substitute t equal to 0, 1 minus 0 is 1. Okay. So for other values, when you substitute other values greater than 1, so just join this and this. Okay. All three dots just join. So find out minus a, when t equal to minus a, the amplitude is 0. When t equal to a, the amplitude is 0. When t equal to 0, the amplitude is 1. Just connect all these things. Okay, you will get a triangular pulse. Signum function, it is a easy function. It is given by 1 for t greater than 0, minus 1 for t less than 0. So for positive values of t, the amplitude is 1. For negative values, the amplitude is minus 1. Okay, so you will get like this. Okay. Sinc function. Sinc function is generally is given by equation sin t by t. Okay. So again, just for your understanding, when t equal to 0, what happens? You will get sin 0 by 0. Sin 0 is what? 0. 0 by 0 is indeterminate. Okay. So you cannot find out the value. So what you have to do? We remember when we get an indeterminate value, what we have to apply? L'Hospital's rule. Okay, we have to differentiate the numerator and denominator. Differentiate the numerator, it becomes cos t. Differentiate the denominator, it becomes 1. Now apply t tends to 0. What is cos 0? Cos 0 is nothing but 1. Okay, so at t equals 1. Okay, and since we are dividing by 2, the signal gets keep on degrading like this and it will reach the infinity. Okay, so you should not draw a sinusoidal signal, you should draw cosine signal. Cosine signal means always at t equal to 0, the maximum amplitude you will obtain. Just draw the curve, it will keep on degrading and it will go up to infinity. Okay, so that signal is nothing but a sinc. Gaussian function. Gaussian function is given by x of t equal to e power minus at square for all t. Okay. Again, when I substitute t equal to 0, what happens? E power minus 0. E power minus 0 per 0 value is 1. Okay. So at t equal to 0, the amplitude is 1. Since they have given for all t, let me consider the left hand side. Okay. And minus infinity, right hand side as infinity. What happens? When I substitute t equal to minus infinity, minus infinity square is infinity, so you will get e power minus infinity is nothing but 0. When I substitute t equal to infinity, infinity square again is infinity, e power minus infinity equal to 0. So here also at somewhere it will reach 0, here also at 0. So just connect a, since e power minus at square, it is like exponential curve, right? It keeps on degrading and it will reach 0. Okay. So you will be having a bell-shaped curve. Okay, from here also it will keep on degrading. From here also it will keep on degrading and reaches the 0. So it is a Gaussian signal. Next is a cosinusoidal signal and sinusoidal signal. Cosinusoidal signal is given by a cos omega t plus pi. Sinusoidal signal is given by a sin omega t plus y, where a is the amplitude, omega is the angular frequency, and pi is, okay. So usually we will consider this phase angle or phase shift we can say. So usually we will consider 0, okay. So we can write cosine signal as a cos omega t, sine signal as a sin omega t. So we are considering pi equal to 0. What happens? Just a cosine signal you have to draw. Okay, draw a cosine signal. So see the difference between this signal and this sinusoidal signal. What is sine 0? Always you should start your signal from 0. Okay. From 0 you have to start your signal like this. Okay. It is a sinusoidal signal. For cosine signal, cos 0 is amplitude A. So you have to start from A at t equal to 0. So you have to draw. That is the difference. Amplitude here you have to start from 0. Okay. So suppose there is a phase shift. Okay. So when pi is positive, you have to shift this original signal by left hand side. Okay. So just remember, when pi equal to positive, shift your signal left hand. You will be able to understand while solving the problem why it is left hand side, why it is right hand side. Pi equal to negative, shift the signal by right hand side. Okay. So just if pi equal to positive, instead of starting from at t equal to 0 the amplitude, you are just left shifting your values. From here you are, actually this duration is nothing but pi. Okay. Similarly, instead of starting from here, you are starting from here. Okay. So if pi equal to positive, left shift your signal and draw the waveform. Okay. For your understanding, I am just drawing here. Instead of starting here, you have to start here. Okay. That's all. Just a left shift. Okay. So this shift is nothing but pi. Similarly, instead of starting from here, you have to start your signal from here. Okay. So this shift is nothing but pi. So you are drawing a left shift value for pi equal to positive. Similarly, you have to right shift your value. Okay. When you see this signal, you are right shifting your signal here. Okay. So next is your real exponential signal and complex exponential signal. Real exponential signal is defined by a into e power at. Again, a value, it can take 0 or greater than 0 or less than 0. When a equal to 0, what happens? Small a equal to 0, e power 0. E power 0 is 1. So 1 into a is a. You will get just a DC signal like this. Draw a for all the time duration. Okay. When a greater than 0, okay, let me take a is equal to 2. What happens? A into e power 2t. Okay. Suppose t equal to 0, what happens? A into e power 0 is 1, so you will get the a value. Suppose t equal to 1, you will get a into e power 2. So somewhat higher than, for example, it will take some 2 like that. Okay. Suppose a equal to, sorry, t equal to 2, 2 into 2, e power 4. Okay, definitely it will be a high value. So similarly, when you take a t is equal to minus 1, definitely it will be lesser value. Okay, so like that it will be going on. So in simple, when you put a higher value in positive side, it will be keep on increasing. When you put negative values, it keep on decreasing. Okay, so you will get the curve like this, exponential signal. Okay, since it is from negative side to right hand side, it is like growing, we can write that it is exponentially growing signal. Okay, and similarly when you put a less than 0 value, okay, so you will decaying signal. Okay, for example, a is equal to minus 2. Okay, if you put t equal to 0, again here also the amplitude will be a. If you put t equal to minus 1, it will become plus 2. Okay, definitely e power 2 will be of higher value. Okay, so somewhat here you will get e power t equal to minus 2, again e power 4, definitely it will be of higher value. Okay, So when you put t equal to 1, you will get e power minus 1, minus 2, lesser value. T equal to minus 2, definitely it will be of e power minus 4, lesser value. Okay. So whenever you have e power of plus value, it will be of high value. E power of minus value, it will be of low value. So just connect all the dots. Okay. So we'll be having a decaying exponential signal. So in simple, for a equal to 0, you will get DC signal. For a greater than 0, you will get growing exponential signal. A less than 0, you will get decaying exponential signal. Complex exponential signal is given by a into e power st, where s is equal to sigma plus j omega t. Okay, so just rewrite this equation. A into, split your terms. Okay, a into e power sigma t, e power j omega t, and e power j theta is nothing but cos theta plus j sin theta. Okay, so using that formula, you are writing a into e power sigma t cos omega t plus j sin omega t. Okay, so we are considering all the cases. First, let me consider sigma equal to 0, omega equal to 0. You'll get DC signal as what we have discussed before. Okay, just we are considering your omega equal to 0. If omega equal to 0, this whole term becomes 1. So only you will have sigma. So it looks like a into e power at. That is your exponential signal. Okay. So here you have a into e power sigma t. Sigma is a real part. So it looks like your real exponential signal. What we have considered previously, you will get DC signal, you will get exponential growing signal, you will get exponential decaying signal. Okay. Suppose I am taking sigma equal to 0. Only you will get what? A into cos omega t plus j sin omega t. Okay. So sigma equal to 0 means x of t become a cos omega t plus j sin omega t. So again you will be getting real part and imaginary part. It is just a cosine signal, sinusoidal signal. So draw a cosine signal, draw a sinusoidal signal. Suppose if you consider both the values, you are considering sigma value also, omega value also, then first we are considering sigma equal to positive value. As we have discussed before, sigma equal to positive means what signal you will get? Exponentially growing signal like this. Okay, since you have here sigma as well as cos omega exponential signal, when you multiply this, cosine signal will be there in the left hand side also. So you have to have a envelope like this. So within this, draw your cosine signal. That's all. Cosine signal means you have the maximum amplitude. So just draw a rough drag this. That's all. Okay. Similarly, it is for xr of t. If you draw for xi of t, I have to multiply sinusoidal exponential. So the same thing, since it is positive, okay, you have to draw a growing exponential signal. Since it is sine, start from 0. So draw your waveform like this. That's all. Okay. So it is exponentially growing cosinusoidal signal, it is exponentially growing sinusoidal signal. Similarly, when sigma equal to negative, okay, you will get exponentially decaying signal. Okay, so just draw a decay like this. Okay, within that draw a cosinusoidal signal and sinusoidal signal. Okay, so I have drawn cosinusoidal signal here. Similarly, draw a decaying signal, within that draw your sin. This signal is decaying cosinusoidal signal, this signal is exponentially decaying sinusoidal signal. Okay, so real exponential signal means this. If a equal to 0, you will get DC. If a greater than 0, you will get exponentially growing signal. If a less than 0, you will get exponentially decaying signal. Next, complex means when omega equal to 0, the complex exponential becomes real exponential signal. So it have all the three cases. When sigma equal to 0, it becomes cosinusoidal and sinusoidal signal. So draw the real part separately, imaginary part separately. When both are there, sigma is also there, omega is also there, then sigma may be a positive or negative. So according to that, two different diagrams for real part, two different diagrams for imaginary part you will be having. Okay. So that's all about your basic elementary signals in CT. Okay. Thank you. Thanks for watching.